Hi everyone, I'm Trevor Haney and this is my Flashlight Design Challenge activity. When using the engineering design process, the first step is ask. For this activity, we had to create an activity that dealt with a paper circuit. So I had to ask, what exactly is a paper circuit? How can I make an activity for high school students, and given the materials I was given, what can I create? The second step of the engineering design process is imagine. In this step, I had to do a lot of research. I spent the most amount of time on this step. I had to figure out how to incorporate this in my electronics unit. I looked at my materials, and after a lot of brainstorming, I decided that I could make a flashlight design challenge for the students. Plan. Plan is the third step in the engineering design process. I used my diagram in the last slide to construct my very own flashlight. I added a switch and some other improvements, like many of my other students would in class. During the create step of the engineering design process, you need to test the product out. For my design challenge, the students would need to create the best flashlight based on the sensor tag 1 foot away from the flashlight. Success would be based on the amount of lumens that were generated from the flashlight. As you can see here, via my sensor tag, the lumens that I was able to get. The last step of the engineering design process is improve. I would improve a lot of this activity. First, I would have more electrical components added, such as switches, a resistor so that the LEDs wouldn't burn out. I would also allow my students to use an online circuit builder to test their circuits before they would start to build. STEM practices. I thought my activity incorporated many practices, as you can see. In the science category, I had ask questions, develop and use models, plan and carry out investigations, and analyze and interpret data. In the engineering category, I had define problems, develop and use models, plan and carry out investigations, analyze and interpret data, use mathematics and computational thinking, and design solutions. In the technology category, I had learn how to use new technologies as they become available and recognize the roles that technology plays in advancement of science and engineering. And in the math category, I had make sense of problems and persevere in solving them, model with mathematics, and use appropriate tools strategically. In my specifications, for the STEM lesson specifications, I believe that for every specification, the activity would be in the yes category. For number 1, I would present it in a real-world problem. Number 2, students have all used flashlights before. For number 3, every group would hopefully have a different type of flashlight that they would be building. For number 4, math and science would come in the form of the students figuring out the type of resistor and voltage drop of the flashlight, which they would learn prior to doing this activity. For number 5, the activity uses the engineering design process, and the students would be scored based on their use of the engineering design process. For 6, I believe that this activity is very student-centered. For 7, they would have their own prototypes that they would need to create to do the activity. For 8, the students are working with electrical technology. For number 9, students should be engaged in this relatively fun activity. For number 10, the testing would be done with the sensor tag, and 11, at the end, students would have to showcase their design. That is my flashlight design challenge. Thanks for watching.